In this lesson, we are going to identify whether or not two events are linked, one happening first and then one happening after. We're going to basically figure out if they're independent or dependent events. For example, is event B dependent upon what happens in event A? So this first problem, it says a litter of puppies consists of black puppies and white puppies. A puppy is randomly selected and then removed from the litter. Then another random selection is made from the remaining puppies. Well, we have two events here. One of them says the first selection was a black puppy. So that's what happened first. And then in event B, the second selection was a white puppy. So the question here is this: does the probability in event B of selecting a white puppy change based on pulling a black puppy out the first time? And the key word here that I kind of brushed over was, once that black puppy is pulled out, it's completely removed. So let's think about it like this. What if I had a litter that was full of white puppies except for one? So I have a white puppy, a white puppy, a white puppy, a black puppy, a white puppy, and a white puppy. Well, if this is my litter, I have 6 dogs in this litter. If I go through event A, which says we pull out the black puppy, so I'm going to erase this one. That one got pulled out. Well, how many puppies are left? Just 5 white puppies. So event B is bound to happen. The second selection is going to be a white puppy. That's 100% probability that it's going to be a white puppy. There's only white ones left. But what if I changed it up? Let's say instead my litter looked like this. Again, I still have 6 puppies, except this time one of them's white and the rest of them are black. Let's go through it again. Event A, the first selection was a black puppy, so maybe it's this one. Okay, let's go through event B. The second selection is a white puppy. Well, since it's removed, we're still down to 5 puppies, but the probability of selecting the white puppy, if we were selecting at random, which it does say in the question, it says random in there. If we're selecting these at random, the odds of selecting a white puppy is pretty low. We have 4 black puppies still here. So you can see that depending on what happens in the first event, it does change what happens in the second event. These are not independent events. One of them depends on the other. So these are dependent, and we can move on to the next one. The next one, it says a family has 2 children. Let's talk about event A. Event A says the older child has brown eyes. And then in event B, both children have brown eyes. Well, I'm going to try to simplify this one a little bit more. Does event B depend on event A? The answer is yes, it does. And here's why. If both children have brown eyes, then you need event A to be true. You need the older child to have brown eyes in order for both of them to have brown eyes. Since there's 2 of them, if they're both going to have brown eyes, then event A has to occur. So let's just say event A didn't occur. Let's just say event A was false. The older child had green eyes. Well, then event B would change. Obviously, both children wouldn't have brown eyes then. So this one is completely dependent as well. Let's move on to the next one. A hat contains slips of paper with the names of boys and girls in a class. A name is randomly selected and returned to the hat. Now look at the difference between that one and the first one. The first one we had removed. The puppy was removed. On this one we are returning it to the hat. So these are different. Then another random selection is made. So event A, the first selection is a boy. Event B, the second selection is a girl. If I'm taking these names out of a hat and putting them back in, it really doesn't matter. My odds don't change for event B. If I have, for example, 15 kids in the class, and I'm taking one out and I'm putting it back in, for both of them, I'll have 15 in the class. And the odds will not change. So for this one, these are independent events. They are independent of each other. A box contains pens. Some pens have ink and some do not. A teacher randomly selects a pen and sets it aside. Think about this, setting it aside. We're starting to come up with some type of pattern that we're seeing here. Setting it aside is the same thing as removing it, just like we did in the first problem. So if we take a pen out and set it aside, then another random selection is made from the remaining pens. So event A, the first selection is a pen with ink. Event B says the second selection is a pen with no ink. Are these dependent? Again, since we are taking a pen out and setting it aside or removing it, that changes the odds for event B. That's changing it. So that if it changes it, that means that we are dependent on that one. And moving on to the last one. At the beginning of each of 2 football games, a coin is tossed, and the winner of the coin toss is determined. This is a pretty straightforward question, I think. If you have 2 games where you are doing a coin toss, are those 2 games linked in any way? Of course they're not. The coin toss is going to be separate for every game. So these ones are not linked. They are independent.